The Littoral Combat Ship, or LCS, was conceived in the early 2000s as a radical addition to the US Navy's surface fleet, promising speed, maneuverability, and versatility in the complex maritime environments near coastlines and in littoral environments. As we shall see, the reality of the LCS fell far short of these aspirations. In the wake of the Cold War, the Navy faced a strategic and operational crossroads. Without the Soviet Union as a clear adversary, the Navy struggled to define its core mission. Traditional large-scale, multi-purpose platforms such as cruisers, destroyers, and aircraft carriers remained essential for power projection. But the emerging doctrine of network-centric warfare emphasized connecting multiple nodes across a conflict environment, including smaller, faster vessels capable of operating close to shore. The shift in doctrine, combined with lessons from conflicts like the Gulf War, led to a perceived need for a smaller, more agile surface combatant that could operate in shallow coastal waters, perform mine countermeasures, conduct anti-submarine warfare, and engage in surface combat when necessary. The Littoral Combat Ship comes in two distinct variants, each with its own physical and propulsion characteristics. The Freedom class is a steel monohull, approximately 115 meters long, with a beam of 17.5 meters, and displaces around 3,500 metric tons at full load. The Independence class is an aluminium trimaran, slightly longer at 127 meters and wider at 31.6 meters, with a displacement of roughly 3,100 metric tons. Both designs are powered by a combination of gas turbines and diesel engines connected through a combining gear system, driving water jets for high-speed maneuvering. The Freedom class is capable of theoretical speeds of up to 47 knots, while the Independence class can reach roughly 44 knots under ideal conditions, including calm seas. However, these speeds have rarely been achievable in practice due to mechanical, structural, and environmental limitations. Both classes feature a flight deck and hangar capable of supporting a single MH-60RS Seahawk helicopter, along with unmanned aerial or surface vehicles. The modular mission bay allows for interchangeable packages to perform surface warfare, mine countermeasures, or anti-submarine warfare, theoretically enabling the ships to adapt rapidly to different operational needs. During the Gulf War, incidents such as the USS Tripoli and USS Princeton striking floating mines in the Persian Gulf highlighted vulnerabilities in mine countermeasures and underscored the importance of specialized vessels capable of operating in coastal environments, including for the purpose of mine clearing. The Navy's existing Avenger-class minesweepers were increasingly seen as unreliable, often spending prolonged periods moored for repairs. At the same time, the Oliver Hazard Perry-class frigates, aging general-purpose escort ships, were approaching retirement. These combined pressures created a clear operational gap. A fleet capable of handling threats in coastal waters, supplementing larger vessels in the fleet, and doing so with lower crew and at lower cost. Secretary of Defense Donald Rumsfeld's 2001 Quadrennial Defense Review emphasized the need for forces capable of countering anti-access and area denial strategies and projecting power in contested theaters. The Navy responded by proposing the Future Surface Combatants Program, or DDX, which encompassed three new ship classes: the DDX destroyer, the CGX cruiser, and the Littoral Combat Ship. Unlike traditional multi-mission vessels, the LCS was designed around modularity, with the capacity to change mission focus through swappable mission packages. A single ship could, in theory, transition between surface warfare, anti-submarine operations, or mine countermeasures. This modular approach promised to keep costs low while allowing for operational flexibility in the creation of a hybrid sailor, capable of performing multiple roles on a lean, mission-critical crew. A nominal crew size of around 40 sailors, with an additional 15 to 20 for a specific mission module, was expected to achieve objectives that would typically require a crew of 200 on a frigate-sized vessel. In 2004, the Navy awarded contracts to 2 industry teams to build the initial prototypes. Lockheed Martin led one team to build the Freedom-class LCS, a steel monohull design, while General Dynamics led the other to produce the Independence-class, an aluminum trimaran design. Both designs were intended to meet the Navy's performance requirements, and the plan initially envisioned a single prototype for each design before selecting one variant for larger-scale production. However, both industry teams argue that producing only one prototype would be cost-prohibitive, due to the expense of idling production lines and design teams while awaiting a final decision. The Navy acquiesced, allowing additional prototypes to be built, ultimately creating more prototype vessels and setting the stage for both designs to enter production. From the outset, the Littoral combat ship program faced criticism and skepticism. Lockheed Martin and its partners mounted an extensive lobbying campaign to secure support, using advertisements, displays, and direct engagement with policymakers to emphasize their expertise and the strategic value of the program. In the end, both the Freedom-class and the Independence-class designs were funded, and the program moved forward despite lingering concerns about feasibility and cost. As the first ships entered service, problems quickly emerged. Both the Freedom-class and Independence-class variants were plagued by mechanical issues, structural problems, and limitations in their mission packages. The Freedom-class ships suffered from a persistent combining gear issue, which connected the ship's diesel engines to its gas turbines. This flaw limited propulsion efficiency, created reliability problems, and required significant maintenance attention. In practice, the combining gear issues on the Freedom-class created severe operational headaches for the Navy. For instance, the USS Fort Worth, commissioned in 2012, experienced repeated propulsion failures during early deployment, forcing the ship to return to port for extended maintenance and limiting its ability to participate in fleet exercises. Largely as a result of these mechanical problems, the USS Fort Worth has been relegated to testing drones and is on track to be decommissioned along with other problematic members of the Freedom-class. Similarly, the USS Milwaukee, which entered service in 2015, suffered a catastrophic combining gear failure in 2019 that left the ship unable to generate full propulsion for weeks while repairs were carried out, highlighting the vulnerability of these ships to mechanical downtime. Ultimately, this propulsion mechanism failed, and the USS Milwaukee was decommissioned due to these failures, among other problems, after less than 8 years of service. These incidents demonstrated that the theoretical high-speed capabilities of the Freedom-class were often unattainable, and that the combining gear flaw imposed both operational and logistical burdens on the Navy. The Independence-class ships, meanwhile, revealed structural defects, particularly cracks in the aluminum hull and deck plating. These cracks were first identified in late 2019 on the USS Coronado, the second ship of the class, and have since been discovered on nearly half of the 13-ship Independence fleet. The cracks occurred in high-stress areas, particularly around the areas of the ship frames where the shell plate meets the deck. The cracks are closely tied to the aluminium construction of the Independence class. Unlike the steel monohull of the Freedom class, the Independence class uses an aluminium trimaran design to save weight and achieve high speed and shallow draft. However, aluminium is more prone to fatigue and stress cracking under repeated load, particularly in high-stress areas like the bow and around critical frames. Naval Sea Systems Command records and temporary standing orders specifically reference cracks in the aluminium hull and superstructure at certain frames, noting that these cracks required speed and sea state restrictions to prevent further propagation. For affected ships, speeds are limited to 15 knots in sea states up to level 4, roughly corresponding to maximum wave heights of 8 feet. This is a massive downgrade from the maximum speed on paper of 44 knots for the Independence class. This limitation dramatically reduces the ship's utility in rough waters, undermining their originally envisioned role as fast, agile surface combatants. These restrictions complicated transits and operational planning, illustrating how structural flaws undermine the ship's original promise of high-speed, flexible coastal operations. Even when repairs were implemented, limited shipyard capacity delayed completion, further constraining operational availability. Efforts to remedy these structural problems include replacing deck and shell plating with thicker material and implementing other modifications during maintenance periods or on new builds. These repairs, however, are complex and expensive. Taking out and replacing structural plates increases the ship's weight, potentially reducing speed and agility. Meanwhile, the Freedom-class ships require repairs to their combining gear systems, with each retrofit costing around $8 million per ship, and facing bottlenecks due to limited shipyard capacity. Operational limitations also constrain mission assignments. For example, the USS Omaha, afflicted by hull cracks, has been restricted from operating in higher sea states and must conduct daily inspections and crack monitoring when underway. While these measures are intended to prevent further structural damage, they also limit deployment's flexibility and strategic utility. Both LCS classes have very small complement, just 50 regular personnel for the Freedom class and 40 for the Independence class. The idea was to rely on the so-called hybrid sailors, capable of performing multiple roles on a lean crew size. In practice, however, the small crew size proved to be more of a liability than a cost-saving measure for both classes. While the concept of mission-critical manning promised fewer personnel and lower operating cost, the reality was that maintaining, operating, and troubleshooting the ships required expertise that the core crew often lacked. Trained contractors had to be flown in frequently to perform maintenance, address technical problems, adding significant expense and logistical complexity. The limited crew also struggled to manage routine shipboard operations, let alone respond to unforeseen failures such as combining gear malfunctions or structural issues, meaning that the theoretical efficiency of a 40 to 50 person crew was rarely realized. Instead of reducing cost, the small crew model often increased reliance on contractors and stretched personnel, undermining both operational readiness and the Navy's original vision of a lean, agile force. The Littoral combat ship program, in spite of the significant technical and operational issues, illustrates the enduring influence of the military-industrial complex. Contractors like Lockheed Martin and General Dynamics leveraged both lobbying and the structure of the acquisition process to secure multiple production contracts. The Navy's concerns about industrial base health and workforce preservation created additional leverage for the contractors, ensuring continued congressional funding even when the ship's operational utility was in question. This interaction between defense contractors, the Navy, and Congress demonstrates how program momentum can persist despite clear evidence of challenges and inefficiencies. By the early 2020s, the Navy faced difficult choices regarding the future of the LCS fleet. In its fiscal year 2023 budget request, the service proposed decommissioning 24 ships, including 9 Freedom-class LCSs. The rationale centered on operational limitations, high maintenance cost, and shifting strategic priorities. Each ship's annual upkeep approached $59 million, and mission packages, particularly the anti-submarine warfare suite, failed to meet expectations. The combining gear issue further complicated Freedom-class operations, and the Independence-class hull cracks restricted speed and deployment options. In other words, despite the billions already invested, the ships could not reliably fulfill the roles for which they were intended. However, Congress pushed back. House appropriators sought to retain 5 littoral combat ships while allowing the decommissioning of 4, directing the Navy to explore alternative uses, such as counter-narcotics and maritime security missions in the Southern Command and Africa Command regions, or potential transfers to partner nations. Congressional arguments focused on fleet size, geopolitical influence, industrial and political considerations, operational experimentation, and symbolic signaling. Even limited capability LCSs help maintain overall ship counts, reassure allies, and project presence in key regions without tying up high-value destroyers or cruisers. Members of Congress also considered the economic impact on shipyards and local communities, ensuring that decommissioning would not lead to layoffs and lost expertise. Lawmakers further saw the fleet as an opportunity to experiment with new systems, including unmanned vehicles and modular mission packages, mitigating risk to more valuable platforms. One of the most vocal congressional defenders of the Littoral combat ship was Senator Jeff Sessions of Alabama, whose state hosts the Austal USA shipyards, responsible for building half of the Independence-class vessels. Sessions repeatedly argued that proposals from successive defense secretaries to curtail the LCS program were both strategically short-sighted and fiscally unwise. In hearings, he emphasized that the cost per hull had fallen dramatically as the program matured, noting that ships coming off the line were around half the price of the earliest vessels. He warned that reducing production numbers would only drive cost back up, repeating the mistakes made with other aircraft and shipbuilding programs where reduced orders led to eye-watering unit cost. Sessions also pointed to the Navy's stated requirements of 52 ships to meet global commitments, stressing that cutting the program to 32 or 40 hulls would make it impossible to reach fleet-size targets. He portrayed the LCS as a flexible, efficient vessel, able to operate independently in low-threat environments and as part of a larger battle force in contested waters. Beyond the numbers, Sessions insisted that the LCS line represented not just warships, but thousands of American jobs and an industrial base that Congress had a duty to protect. In his view, trimming the LCS program undermined both naval readiness and the economic stability of shipbuilding communities, and he vowed repeatedly that this matter is not over. The push to retain the LCSs was bipartisan but nuanced. Some lawmakers, like the House Armed Services Committee Chairman Adam Smith, emphasized fiscal prudence and warned against maintaining ships purely for quantity, arguing that the Navy should focus on quality and readiness. Others highlighted the supposed value of retaining a flexible fleet for global presence and regional missions. Critics pointed to the ship's repeated technical failures and questioned their combat value, while proponents underscored potential alternative uses that could free up higher value vessels for operations in the Pacific, particularly in the contested South China Sea. Debate extended to the potential sale or transfer of decommissioned ships to allies such as the Philippines, which operates older Coast Guard cutters, providing a path for capability sharing while maintaining a strategic footprint. From a strategic perspective, these limitations erode the Navy's ability to project power and maintain credible deterrence in contested regions. While the LCS program was designed to supplement larger platforms and offer specialized capabilities in littoral environments, technical and operational shortcomings have limited their utility. Missions such as anti-submarine warfare and fast surface engagements have proven difficult to execute reliably. In some cases, the Navy has repurposed the ship for lower-risk missions, such as maritime security patrols in the Americas and other regions where adversary capabilities are limited. While these deployments maintain a degree of fleet presence, they fall short of the high-intensity combat scenarios envisioned during the program's conception. In general, LCS is also generally not economical for the low-intensity missions that could be far more efficiently filled by cheaper, dedicated patrol ships. The Littoral combat ship program also illustrates broader challenges in defense acquisition and industrial policy. The Navy's reliance on a small number of shipyards, combined with the lobbying power of major defense contractors, created incentives to continue production despite clear signs of technical issues. Congressional decisions often balanced industrial base preservation against operational effectiveness, leading to the retention of ships that were costly and imperfect. The program demonstrates the tension between strategic requirements, political considerations, and industrial realities, highlighting the complex interplay that shapes the composition of the U.S. Navy. Despite these challenges, the LCS program offers lessons for the future. The modular concept, while ambitious, illustrates the difficulty of designing multi-mission platforms with limited crews and lightweight hulls capable of handling high-stress environments. Structural design and propulsion reliability remain critical factors that cannot be sacrificed for flexibility or cost reduction. Additionally, the program underscores the importance of aligning acquisition processes with realistic assessments of technical feasibility and operational need. Lobbying influence, industrial-based considerations, and congressional pressure can sustain programs beyond their practical utility, creating long-term budgetary and operational consequences. Positively, the U.S. Navy has made some promising progress in adapting the Independence class for mine countermeasure operations. By 2025, the service had successfully integrated advanced mine detection systems, unmanned underwater vehicles, and modular mission packages, allowing these ships to conduct more effective mine hunting operations in coastal and littoral environments. This development demonstrates that, even amid structural and programmatic difficulties, the modular design of the Independence class retains potential for specialized roles, offering the Navy a degree of operational flexibility that could offset some of the broader limitations of the class. This upgrade also helps the Navy to address one of its long-standing weaknesses in relation to mine countermeasure and mine warfare, especially as their aging Avenger-class minesweepers are gradually retired. The Littoral combat ship program represents the intersection of ambition, industrial influence, and operational compromise. Conceived as a flexible, fast, and modular platform to fill a critical niche in the post-Cold War Navy, the ships have struggled with structural defects, propulsion failures, and the limitations in their mission modules. While billions of dollars have been invested and lessons learned, the Navy continues to wrestle with the fleet's utility and the broader implications for surface warfare readiness. Congressional resistance to decommissioning the ships illustrates the enduring influence of industrial and political considerations in defense policy, ensuring that the program's legacy will continue to shape discussions on naval procurement and fleet composition. The LCS program remains a cautionary tale in U.S. naval history. It demonstrates how platforms that may appear innovative on paper can often struggle to deliver in the real world. At the same time, the story highlights the Navy's efforts to extract value from these vessels, repurposing them for secondary missions, experimenting with modular capabilities, and maintaining fleet presence. Ultimately, the Littoral combat ship story is one of persistent challenges and competing and often incoherent priorities. Even as the Navy looked toward future surface combatants designs, including larger and more capable frigates and destroyers, the LCS program offers enduring lessons in acquisition strategy, fleet management, and the consequences of pursuing unhinged innovation.